So in this case, we are going to simplify without the use of a calculator this question. So that's a 3-mark question that we are given that you're supposed to work out without the use of a calculator. Actually, we can simplify this on our calculators and use the simplification to verify the answer that we have obtained. Let's say we have got 3. That's the square root of 12. Then we are going to subtract the square root of 75 like this. So you can see that you're going to obtain the square root of a 3. So as you are working out, you know that the answer there is supposed to be the square root of 3. All right, but how can we obtain that without the use of a calculator? All right, consider the first number that we are given. This is 3 square root of 12. Under the Surds, we do understand that we are supposed to have our numbers in simplest form. The number that is supposed to be under the square root is supposed to be in simplest form. So how can we obtain the simplest form? Just consider the perfect squares in these numbers that are under the square root. You're supposed to consider the perfect squares. So if you're considering the perfect squares, remember 1 squared, that's a 1, but you cannot talk of a 1. So you just start from 2, 2 squared, which is a 4, 3 squared, which is a 9, 5 squared, which is a 2, and so on and so on. These are the numbers that you're going to actually be trying to work with in the simplification, the perfect squares. So you're asking yourself, okay, how can I rewrite the same square root of 12 with a perfect square inside? We must have a perfect square. Is it going to be 4? Is it going to be 9? But that perfect square times a certain number, we get what? 12. So we're talking of whole numbers, the integers. So can we use a 4? Let's divide. 12 divided by a 4, it is going to give us a 3. Meaning say 4 times 3 is what? Is 12. So this 12 that we are seeing can be written as what? 4 times 3. So we're talking of the large, the bigger perfect so that we can consider. We cannot use 9 there. We are going to have remainders. We are supposed to have whole numbers. If you divide 12 divided by 9, 12 divided by 3, are you going to have a whole number then? All right. You do the same thing on the square root of 75. Can we use a 4? It cannot work. It's going to give you a decimal. It's going to give you a decimal. You move on to 25. Dividing this 25, that's 75 divided by 25. This is going to give us a 3. Meaning to say the product of these two, 25 times 3, is going to give us what? A 75. We have a perfect square. Why is it that we are worried of the perfect squares? Because we can determine their square roots. We can determine the square root of 4. We can determine the square root of 25. Remembering that the square root of a, b, like this, can be separated to give us the square root of a times the square root of b. So in that same sense, this is what you're going to do here. You separate. So it was going to be the square root of 4 times the square root of 3. Minus, you separate these two. That is the square root of 25 times the square root of 3. We know the square root of what? The square root of 4. That's a 2. So meaning to say we can simply multiply 3 times 2. That was going to give us 6. Square root of what? Square root of a 3. Minus, you do the same thing, the square root of 25. We know it. That's a 5. So that's 5. But we cannot simplify the square root of 3. So it's going to be 5 square root of 3. So here we are, guys. How are we going to simplify thereafter? These numbers under the square root are the same. Square root of a 3, same as the square root of a 3 that we are given. So it allows us to subtract the coefficients, which is the numbers that are on the root, the 6 and the 5. So 6 minus 5 is going to give us what? 1 square root of 3, which is simply the square root of 3. So take note, as you are working with the sets, addition and subtraction is only possible if the numbers under the square roots, they are the same. Just like we're given 6x minus 5x. Remember, I talked about this. So it's just the same thing, x and x. So 6 minus 5, that's 1x, which is same as x. So if you are given, as long the numbers are the same, but the moment that you are now working with something like maybe 6 square root of 2 minus 5 square root of 3, we cannot subtract this. It's impossible for us to subtract. We just have to leave it like that. Only if the numbers under the square root, so meaning to say it can be taken from 6 square root of 2, it can be addition plus 4 square root of 2. What is important is the numbers under the square root 2, square root 2. So we can simply have the 6 and what? The 4 added together. 6 plus 4, which is going to give us what? Which is going to give us 10. Square root of what? Square root of 2. So these are laws which are governing or which we are working with as we are having our sets. In terms of multiplication, we saw that multiplication that we had. So you must know how to have the perfect square from the bigger perfect square. So let's say I do not know these perfect squares. I do not know the perfect squares, like which perfect square am I going to use? What can I simply have? How could we have simply worked out this? The square root of 12. So the square root of 12, we can simply have this as prime factors. Smaller number, which is 2 into 12, that's a 6. 2 into 6, that's a 3. 3 into 3, that's a 1. So in this case, the numbers that a number that has got a pair like this one, this is a pair of 2. Once you have a pair like this, the number with a pair is to be written out of the square root. So this one is written outside. The number without a pair is going to be written inside of the square root. So meaning to say the pair of 2 is going to be written outside of the square root. So it's going to be 3. There we have got 2. That 2 out of the square root, it's a pair. We say a pair of 2. A pair of 2. The 3 that is remaining under the square root. Minus, you do the same thing on the 75, right? So let's say our 75 is product of its prime factors, the smaller number 3 into 75, that's a 25, 5, 5, 5, that's 1. So in this case, we can see that there's a pair of what? A pair of 5. So a pair, like I said, you write it outside. Without a pair, inside the square root. So means say this 5 was going to be written outside of the square root. The square root of 75, I mean the 3 that is remaining there inside of the square root. So let's say you are using this method, guys. I want you to be very careful now. You can see that this is a working on its own, but what you are writing is this answer. So meaning to say under an exam condition, even if they say do not use a calculator, this is what you're going to do. You use your calculator to simplify stage by stage. Don't use your calculator at once. Because maybe you do not even have these basics, guys. You're under exempt condition. Just take your calculator. You simplify. What is the square root of 12? You're going to obtain 2 square root of 3, which is exactly what you have here. You write your answer. You do the same thing, the square root of 75. What is the square root of 70? Stage by stage. 5 square root of 3. Guys, this is exam. You're not supposed to lose marks because you do not know how to simplify the cells while the calculator is there. No one is going to understand that you have used a calculator here or which method at that stage. So you can simplify even that way. All right, let's multiply 3 times 2, that's 6. Square root of 3 minus 5 square root of 3. As we had before, 6 minus 5, that's 1 square root of 3, which is same as what? Which is same as the square root of 3. So let's continue to revise as much questions as we can. Questions can be given like this. You just have to figure out what is it, how to simplify, and if possible, how to use a calculator where it is not allowed. You can actually use it, but in a way, there's a way that you're supposed to do. So try to figure it out. Let's do revise as much as we can.